Hello, everyone. Happy Friday and welcome back to another fantastic guest webinar presentation. My name is Damien and I work with all of our manufacturer partners, and I will once again be in the background moderating today's webinar. If you were attending our webinar on June 19th about rooftop amenity hardscapes, you'll know that we are lucky enough today to have someone back so soon to present another hardscape topic, which I think has been probably similarly long awaited on our video platform. I am, of course, talking about permeable surfaces with concrete pavers, which is being brought to us by Brad Swanson of Unilock. I won't say too much further on the topic because of the in-depth presentation that Brad has ahead of us, but I will say that I think most of us in the landscape design industry get really irked by surfaces that just collect and redistribute water in a truly unuseful manner. It's just such a pain to see pools and pools of water along our streets and so on. And we want to obviously have surfaces that, you know, do something a little more useful with that. So Brad is going to share with us today some of the solutions that are on offer that both allow for hardscapes with permeable characteristics. Before I hand the mic over to Brad, we'll just go over our quick and usual housekeeping items. We love to see your your questions come through, and I know our presenters are more than happy to hear and answer those. So when you do have questions throughout the webinar, please type them into the Q&A window, which can be accessed by clicking on the Q&A button on your screens. Some questions will be directly answered by me. Otherwise, Brad will have a moment, in the presentation to answer those questions. And we will also have some time at the very end to get some questions over to Brad to answer live. If we do run out of time, we'll be able to send those unanswered questions over to Brad so that he and those people can continue a bit of a dialogue offline and get all the questions answered. But from here, I will hand over to Brad to introduce himself if you do not know him already from last presentation, and he can get us underway. Thanks, Brad.
Thanks, Damien. And thanks to LandFX for allowing us to do this presentation today. Welcome to Permeable Surfaces with Concrete Paving. Our focus today will be on how the system works and the materials that go into this, so I'll kind of cover that. To give you a little bit brief background on myself and our company, I am the Director of Commercial Sales for Unilock Midwest. I work only on the commercial side, working with specifiers to help find the right product for their projects, both permeable, non-permeable, roof decks, etc. But my background's in landscape architecture, so I did practice for 12 years before crossing over the dark side to become a product rep. So my background is with a bachelor's of landscape architecture. So I did practice for a few years before starting at Unilock. One of the most important things is my contact information. So if you do have questions that, in the future, you know where to find me. A little bit on the company, we've been around since the early 70s. We've got several locations around what we call the Great Lakes states. We're originally from Canada. We have our headquarters is up in Toronto, Ontario, Canada, but we do have all these different locations for manufacturing. And we're really known for our extensive dealer and contractor network. We first introduced paving stones to North America in 1972, and we since have grown that throughout North America, mostly, like I said, in the Midwest or upper Northeast states, and we introduced some key technologies in the industry. Besides concrete pavers, architectural slabs, we do have natural stone and porcelain tiles. We also have an extensive retaining wall line, which is always helpful to know about as well, because those can go hand in hand with some of your permeable paving projects. And then we do offer precast and accessories for all our materials. Some of our learning objectives today, we want to identify the benefits and opportunities for using permeable pavers and permeable systems. We want to analyze the goal and criteria for using those permeable paver systems. I want to talk about the different materials that go into the system and how those work. We'll evaluate and compare to other, traditional stormwater systems. And then I also want to talk about the different installation procedures for these systems. In terms of our agenda, kind of the sections that we'll go through, these are the key sections I want to talk about. After section 3, the benefits and systematic solutions for permeable surfaces with concrete paving, we'll try to take a pause there and answer any questions. That section is really heavy on the stormwater, so I kind of want to focus on that, and usually we have some good questions after that section. So general information on permeable pavement systems. This project here on the left is actually from the Museum of Science and Industry. This is their main bus drop-off area for a lot of the kids that come down to this from schools. So they drop these kids off in these different bays and the buses turn and go out. So this is a permeable project's been in for 6 years already, believe it or not. Conceptually speaking, permeable pavement is designed to let water go back through the surface, get back down into the ground, recharge groundwater, provide water, oxygen for plant material. But the main reason we're seeing it being used in the Midwest is in the Northeast, Unilock territories, is because you can use that stone base for detention. So that water can be detained there for a period of time, eventually soak back into the ground, or if necessary, drain off slower to reduce that first flush effect of storms. When people think of pavement, they often think of that as the decorative part of the design. This is actually someone's patio where they have concrete pavers in a different arrangement to look like a dragon and shoots fireballs over to a fire pit. Certainly there's some options for doing things like that with decorative concrete or stone. In this example is concrete pavers. But pavements are also designed for heavy duty use. So all around the world there are many ports with pavers in the container yards, concrete and asphalt surfaces as well. We need to be able to have these functional for heavy duty traffic, and concrete pavers allow for that at a very inexpensive cost over a 20-year life cycle. So when we start to look at the project versatility of permeable pavements, you can see that not only the aesthetic, they're heavy duty, so you can drive cars and trucks and forklifts across them, but they're functional in a new way that allows water to infiltrate through the surface of the pavement and get back down into the base and into the subgrade soils. So that's the conceptual idea of how it works. And then I always like to mention to people that, just by going from a non-permeable pavement design to a permeable system doesn't mean you have to sacrifice design intent. Great designs will transcend regardless of material type. So in this project here, this is out at Stonehill College on the East Coast. They're using a very basic Unilock paver here with 3 different colors. They've used banding in this area. They actually have some, you see the little aluminum covers there for a little knockout spot to put a tent structure down. So they can turn this into a 4-season room if necessary. You could do this with other materials. This is completely flat. There's no inlet, so the water will go right back through. So it does give you a different aesthetic for that. And another project here I just want to mention real quick. This is downtown Evanston here in Illinois, right outside of Chicago, where we're seeing a transformation of these urban spaces to allow more seating, which is very timely for kind of the COVID world we're starting to live in now. But this is a decorative permeable pavement here in this urban plaza. So I just wanted to kind of share that. Some of the case studies, a little bit more in depth, I want to talk about. This one here on the left is a project where they close a street off and they turn this into a community plaza for these restaurants and adjacent storefronts. But the key projects here, I just want to mention some so you get a better idea of the scale for some of these projects. You know, you can go from anything smaller like a residential driveway all the way up to these larger projects. So I just kind of want to mention that and show you what some of these look like. This first one here is at Loyola University in Chicago, where they have a permeable pavement system that is in some different colors and sizes, but this is designed to have all the water go back to the surface, back down into the subgrades. They have about a 14-inch infiltration rate into the sandy soils because this is literally a few hundred yards away from the lakefront. So all the water is going to go back down into the subgrade soils and drain that way naturally. There are no inlets out here on the surface. It all goes to the joints, which are about a 1/4 inch wide, filled with a chip material. We'll talk more about the specifics of the system in a little bit. The other thing to look at here is that they have two colors to delineate the bike lanes from the walking lanes, but also these are very wide, so they can get fire trucks down here if necessary, other emergency vehicles, maintenance, things like that. So you can drive a fully functional vehicle down this if necessary. This was an old street that they actually closed off and turned into this community plaza. The next project I want to mention here is the Guaranteed Rate Field, home of the Chicago White Sox. This is where they have their parking lots here south of the stadium. And this Lot L back in 2007 was just a gravel lot, but they needed expansion based on them winning the World Series in 2005. They thought they needed more space, but they haven't won a World Series since. I digress here, but when they put this in, this was the largest permeable lot in the country at about 265,000 square feet when it was installed. They originally designed this to be a traditional parking lot design. Back in 2007, the city of Chicago did not have anything in their stormwater guidelines for permeable pavement, so they designed it very traditionally, and then the mayor wanted to try to enhance how this is going to work and be more green, so they looked at an additional option of permeable pavement. But the traditional design that they did would have included 44 surface inlets in a grid pattern 50 to 100 feet apart, over 3,000 linear feet of reinforced concrete pipe to connect all these inlets, and they would have had to include a 73,000 cubic foot storage tank to temporarily hold all that water before it was released into the city of Chicago stormwater system. All this accounted for about $2 million in underground infrastructure costs that would be completely buried. All you would see is the inlets on the surface. So he took a step back and went and looked at the drawing board to see, well, what would it cost if we did a permeable pavement system out there with eliminate all the inlets, no reinforced concrete pipe or under drain, no storage tank. And they were able to do that because they had a 14-inch hour infiltration rate, again, because they had an old sand bed underneath the surface from the old lakeshore. So this saved them about 15% versus the traditional, even when you included the surface costs of the pavers. They had about a 14-inch base, so just doing some quick math, they're able to eliminate that stormwater tank because they had about 123,000 cubic feet of storage. They only needed the 73,000. So they actually had a 50,000 cubic foot surplus of storage out there. And we'll talk more about how this works as well. But just to give you an idea, they were able to eliminate that storage tank because all the material is stored in the base. Here's what it looks like during construction when they were putting this in. This is a mechanical installation device. I'll show you a video on that a little bit later. They have two colors out there. They have a charcoal and a granite color for the drive aisles and the parking aisles. This is designed to kind of keep cars in place in some orderly fashion when they come in and leave. This is part of a plan development, so they did not need to have any landscape islands out there, unfortunately. The next project I want to mention is the Buckingham Fountain. If you've ever been to Chicago for anything, this is an iconic fountain right down in Grant Park. The center area where the fountain's at, where you see the outline of the green grass there, that fountain is about 1 acre. So originally this used to be old pea gravel, or decomposed granite. It's kind of a combination of both, I think. Surface, it really wasn't accessible. So you couldn't get out there in wheelchairs very easily. There's a lot of wedding photos taken out there, so people in high heels would have trouble. So they wanted to make this a little bit more user-friendly. They decided to look at doing many different types of systems. They ended up landing on permeable pavers because it just was the best option for their situation. When they put it in, I still think today it might be the largest permeable plaza in the US, about 235,000 square feet. They started, when they started installing the pavers, they put them in starting at the pump house. They worked counterclockwise from about, you would on a clock about 4 o'clock all the way around to about 11 o'clock, and they stopped. The contractor went back to the starting point, and they worked around counterclockwise from about 4 o'clock to 11 o'clock and zipped this up. So it's one giant segmental monolithic paving surface. They used about 44 or 40 stones in this lane pattern. This is actually the lane pattern they used to put this in, so you can't see the repeat as often. It's much harder to pick up when you're out there on site, which was intended to meet the historic preservation's requirements. So that's kind of what it looks like when it's been installed. This has been in now for 11 years now. It opened its 11th year in April. Benefits and systematic solution using permeable surfaces with concrete paving. This is a apartment complex here where they have a running bond paver with this actually has 8 paver shapes in it, and this is designed to be mechanically installed as well. Some quick facts about permeable pavement. It is considered a best management practice by the EPA as part of their National Pollution Discharge Elimination System. It does reduce runoff temperature. It can improve the water quality as it flows to the granular base. And again, as I mentioned earlier, detention storage in the base. So I'll talk a lot about these in the next few slides. A lot of engineers always want to know what the runoff coefficient is, the C value. In actuality, it's 0, but most municipalities or jurisdictions won't allow for that. But typically you might see something anywhere from 0.25 to 0.5, which means that anywhere from 25 to 50% of the water that hits that surface will run off. I think it's much lower than that. Some jurisdictions will look at permeable pavement as a detention pond. So detention ponds have a runoff coefficient of 1, meaning all the water that hits that surface is going to drain. With some of the best management practice, they may allow you to calculate that down. So from 1 to, let's say, 0.95, which is actually a pretty big difference. And then the infiltration rate really will vary depending on the soil permeability, which is what the curve number does. It looks at ranges for the surface infiltration and back into the subgrade soils. So I kind of want to step through these different benefits and kind of explain each one of these. So let me just start on these. This is a example of permeable pavers where we're just going to pour a gallon of water on the surface just so you can get an idea of how it functions. Now the water is splattering out away from where we're pouring it, but essentially the water only has to run a few inches before it actually is in the system and starting to be cooled down and filtered as the water flows through that system. So it won't take much for that water to drain off the surface, and it doesn't have to run across the parking lot 50 feet to an inlet, picking up debris and other heat and things like that, oils and chemicals. It goes right back into the system. Typical infiltration rates off the surface for different products could be anywhere from 500 to 900 or 1,000 inches per hour. And the flow rates of the base below that are generally over 500 inches per hour, and they'll flow through that. And we've done measurements on that, different materials using different ASTM standards. So in terms of volume control, this is one of the first projects we had in the Midwest here out at Dominican University back in 2013. This was designed to accommodate a 500-year or sorry, a 100-year storm event. The base is about 20 inches deep or so. So one of the challenges they had on site here was they had a lot more commuter students coming to campus. They didn't want to encroach on all their green space with detention ponds, like their athletic fields. So they created this permeable system here to use it for stormwater. So they're actually stacking their detention pond and their parking on top of each other to accommodate that water. They also didn't want to smother out any trees they had on here. You see a lot of large oak trees in this photo. They wanted to make sure those still stayed healthy. And I can attest, I was out here, I think a year ago, and this parking lot is still functioning very well and still performing, meeting their expectations. As I mentioned in the last slide, you know, tree root growth zone is important to get oxygen and moisture. So using permeable systems will allow water to get back down, especially for these older existing trees where they already have their roots further out. In this case, they needed to enlarge this plaza area. They didn't want to completely suffocate this tree, so they put in the permeable pavements around it when they installed it. Now this compares to the, or I should say contrast to the large big box retail where you may have these little tree pit areas where they're 5 by 5. The tree roots really have no reason to grow out underneath that asphalt or impervious surface because the roots have no moisture or oxygen in those areas. Eventually they'll get root bound and they'll start to die or if they don't get irrigation. You can see in the background in this photo the trees actually has passed and been removed. The way that it decreases pollution, I always kind of explain this as kind of like a Brita water filter for the environment. As the water flows through that granular material, it's going to capture sediment, any kind of contaminants that are in the water, and help filtrate that out. So when it gets down to the subgrade soils, there's a dramatic reduction in any kind of contaminants that are in the water. The research has found that in that top 1 to 2 inches of the joint material, where the arrow is going in, that's where most of the filtration occurs. That's where it's going to capture it. It's the smallest particle size. That's where you're going to see the big changes in the water quality. There's been multiple studies done across the U.S. You'll find, if you do research on that, the EPA, different colleges, like Wisconsin DNR has done some testing as well. And they find generally the same things as this study done by the Interlocking Concrete Pavement Institute, where we're looking at removal of materials such as suspended solids, phosphorus, nitrogen, and heavy metals. So if you look here, your typical infiltration trench on the left, and then your infiltration trenches with permeable pavement combined, you see a 95% removal of TSS. Most municipalities like Wisconsin want an 80% removal, so this far exceeds that. And then metals up as high as 99%. In terms of volume control, we've found success with this being used for detention reasons because people have limited space in these urban environments for a surface detention area. Sometimes the underground vaults can be very expensive, so this is a good way to reduce cost and actually allow you to have more land use options by using permeable pavement. So you have less impervious coverage for spaces, increase the usable space for other areas. So like on a college campus, you could add another building. And really a key thing that gets overlooked a lot is that first flush. So when you get those heavy rain bombs that come down, you get all that heavy rain for about 15 minutes or so, and then it all rushes downstream and causes other issues. This can actually contain that water on site for a duration of time so it doesn't have that kind of issue. So when you're looking at doing new development, you should always try to maintain or reduce the post-development discharge from the pre-development discharge. You really want those to balance out so they don't, you don't increase that for your neighbors. I'd like to take a little bit more in-depth look at the detention capacity because again, that's a key feature of the system. So if you take a look at a 1 acre parking lot, let's say for an example, and you get a 1 inch rainfall, that's going to generate about 27,000 gallons of water. If you have a 12-inch base depth, you might be able to hold up to 130,000 gallons of water, depending on your stone size, but typically at a 40% void space, you'll get about 130,000 gallons. So you're only using about 20% of that capacity for the system. The highlight here I showed is a 5.11-inch rainfall over 1 acre with about a 13-inch base. You get to close to 98% of that volume. So that's a pretty big deal in terms of you're almost maxing out that system. So I selected that storm because that's about 3.8 gallons per square foot per hour of water. And that did occur back in April of 2009. I was out at Buckingham Fountain. I had this giant storm bob come through, and that's ended up what the rainfall event was for that period of time. Back in April, we had about 13 inches of rain. This May, 2020 in Illinois and Chicago, we had about 8.5 inches of rain. But the Chicago monthly average is only about 2.93 inches per month, about 35.1 inches annually, including snowfall. So we don't get a lot of moisture here, but that's pretty typical of the Midwest. You'll see a lot of ranges in that area. Even out east, you'll see New York's a little bit higher, but most of the cities out east are in that same kind of 30 to 40 inch rainfall. Even out west in like Seattle, where you think of it getting a lot of rain, they're still in that 20 to 30 inch rainfall events. And so when you start to look at some of the jurisdictions around your municipal stormwater codes, you might see things that show a 2, 10, and 100-year rainfall quantity event. So this is from, this example is from the Metropolitan Water Reclamation District, which covers kind of all of suburban Cook County around Chicago. And this shows you what those capacities might be for the different base thicknesses for those rainfall events. I think a better way for me to look at it is actually this chart, going back to the chart I just showed you. So you see here on the left where it says rainfall in inches, the 3.02 is the 2-year, the 4.47 is a 10, and the 7.58 would be your 100-year rainfall events. And so we've put this in the 14 to 22 inch, stone depth base there, so you can kind of see where those max out. And even on a 10-year event with 14 inches of base, you're only using about 80% of that capacity. So you can really capture quite a bit of water in those areas. It's not till you get up into the 100-year rainfall events with your 22 inches that you'll capture it. But if you're only looking at like 14 or 18 inches of stone base, you're actually going to max that out. You're going to have runoff off the surface of that. So that's why you do need to accommodate any kind of surface runoff or have the ability to capture that water as it runs off the surface. So your local stormwater issues may look at some sort of data. In this case, in Illinois, they look at the water survey bulletin. Over a 24-hour period is always what they look at for your 2, 10, and 100-year events. So you can easily find this online if you do some quick searches. There's multiple things out there like that. But one of the things I always want to point out, one of my pet peeves is when I hear things on TV about the 100-year rainfall event. Really, when they talk about these, events, they're really a percentage of chance, probability. So a 100-year rainfall event is a 1 in 100 chance. So 1% chance that a storm that comes through drops that much water on the surface to cause issues. So keep that in mind. You'll see people on TV that'll be like, oh, I've lived here all my life. We've had 3 100-year rainfall events in the last 5 years. Well, that's not what that means. It means it's a 1% chance. And just to put some things in comparison, Hurricane Harvey back in 2017 dropped 50 inches of rain in Houston in 24 hours. A 1,000-year event in Illinois is only about 10, 11 inches of rain. So that just puts in perspective how much rain a hurricane can drop on an area. Now, the other thing you need to think about is intensity. So quantity is one thing for the detention, but getting the water off the surface of the permeable system back into the subgrade is very important. So you got to know how intensity affects that performance. So in this case, we're looking at the bulletin for your intensity for your 2, 10, and 100-year events. And we're only looking at the 5-minute event because that's going to be the most rainfall amount, or that's going to be the heaviest intensity that you could possibly get. So the infiltration of the permeable system must exceed the intensity. So keep that in mind. And the way that we do that is that we take this single ring test. We put some plumber's putty around there and we pour water on it to calculate how fast that water drains through these permeable systems using ASTM C 1781. And so we've measured all our permeable systems, and it's a good way to take a quick look at what that capability of that system is. So if you look at this top one up here, this one that says Ecoline, it has a typical joint material of this ASTM number 9. The joint width is about 6.25 millimeters. So the overall void space of that system is about 5.8 inches per hour, or 5.8 inches, or 5.8%, excuse me. The infiltration rate is about 560 inches per hour. Now, the numbers in green on the right show you the the minimum infiltration rate for each rainfall intensity. So the 2-year per hour would be less than a 2-year rainfall event. The 4.5, the 6.5, and the 11 inches per hour are your 2, 10, and 100-year intensities for 5 minutes. So the way that we calculate the minimum infiltration rate is to take the inches per hour and divide it by the void space ratio, and that's where we get those numbers. So the 2-year at the 4.5 inch rainfall intensity is showing 78 inches per hour. So what that means is that for that watershed of the paver, the water has to flow off the surface of the paver through the joints at least 78 inches per hour. Otherwise, you'll start to generate runoff. So if you go to the 6.5 inches per hour, the number goes up, 11 inches goes up, because you got to get the water off the surface faster. So another way to look at it for that example here, you're only looking at about using 13.8% of the maximum infiltration rate. So that 78 is only 500, of that 560 is only 13.8%. Now, in terms of quantity, most of the storms that you might see, even in your area, I know this is for Chicago again. I'm sorry, I'm in Chicago, so a lot of my data is from that. But if you compare, you'll see very similar things in your area. But 98% of the storms are 2 inches or less. That's quantity, not intensity. 95% are 1 inch or less. So you get a lot of rainstorms where it'd be a 1/4 inch, a 1/2 inch, 3/4. You don't see a lot of these bigger storms. But within the last few years, you probably noticed in your area, you see bigger and bigger storms. Like I said, in Chicago, we had 8 inches of rainfall in May, and we start to see rainfall events that are in the 3-4 inches on a more regular basis. And that, I believe, has to do with climate change. As the environment heats up, it's going to carry more water. So when it hits those cold masses, it's just going to bomb the rain down, straight down. So over the next 20 years, we're going to see an increase of those extreme precipitation events by 10 to 20%. So if you start to look at some of the existing stormwater ordinances in your area, they may not incorporate permeable pavement, but they're going to start to see challenges with these this increased climate change activities. So you need to have these best management practice for green infrastructure into your municipal codes, and you need to start working on getting those in place. Here in the Midwest and Northeast, we do see a lot of questions about, what happens in the wintertime when these things freeze. This is some data we obtained from the Illinois EPA for a project we worked on in the city here. We actually put probes in the base and soil, and what they found were that on this date in January 16th of 2009, the air temperature was -7 degrees Fahrenheit. The probes that were in the soil were all above freezing. So those are in degrees, not in inches, showing 38 to 33 degrees. And so even though the air was below freezing, significantly below freezing, water could still infiltrate. So if the next day this warmed up and it rained and water would drain, it would drain into the subgrade soils and go back into the ground. So even when the ground's frozen, you'll actually see some capillaries that will capture and drain some of the water. So we've seen other studies really looked at a longer period of time where they've actually seen that it takes longer for the subgrade soils to freeze, and they warm up sooner with permeable system because there's some breathing action that goes in those open graded stone in the base. We do often get asked about snow removal in the Midwest, so you can snow plow pavers. That's not an issue. You can snow plow permeable pavers. We highly recommend that you use something with a rubber tip on it so you don't grind the surfaces, but you're not going to pull those pavers out. In this example, you can see where they snow plowed snow across from left to right, or from right to left here, and piled it up against the tree area there. and you can see the curl of the snow plow. So you can do that. Some of the studies we've heard from owners actually doing the kind of the study themselves, they actually use less salt or de-icing chemicals on their permeable systems than they do on the asphalt, because once the snow melts, it drains away. You don't have to go back out and resalt that. This is an example of what a steel tip plow can do. It leaves little rust particles behind, and then or little steel particles behind, then it will rust. You can see where in some areas they actually ground off the surface of paver, but didn't pull it out or chip it. That's just one of the hazards of using a steel tip. If they used a fiberglass or plastic tip plow, it wouldn't do this kind of damage. And then in this photo also, I'll mention, you can see that little cigarette butt there. That is a hazard of permeable pavement. You can certainly clog up that system, which is a challenge. So I do want to kind of mention preventative and restorative maintenance for permeable systems. It's always something to keep in mind. And that could be as simple as taking a broom and just sweeping off any kind of debris that gets on the surface. If you have any kind of trees around, they're constantly dropping leaves and branches and all kinds of different debris. It's good just to sweep those off. If you're doing some like annual plantings and you get some soil in the joints, it's always good to go out there even with a shop vac and vacuum that up. So like if you're working with some schools and owners that are like, oh, we don't have any special equipment, you can point out that there are some things that are out there that easily do preventative maintenance. All landscape companies have some sort of leaf blower these days. So if they're out there trimming shrubs or getting grass clippings on the permeable systems, make sure they clean those up and don't leave those there to get packed down into the joints. One of the other options is these rotary brush sweepers. These actually work really good for not only getting rid of any dust and debris, but also cleaning off the surface crust for permeable systems. And some college campuses will actually use these in the Midwest here for snow. When you see snow that's generally under, like an inch or so, it gets packed down very quickly. Sometimes it's harder to snowplow, so they'll go out there with the rotary brushes and kind of sweep that off. But this actually works great for cleaning the system. I see the Chicago Park District using the sweepers all the time along the running path to get the sand off the surface, so they do work well. There are some industrial sweepers out there that can actually sweep and vacuum up the surface. Those work well if you have those options. Some of the municipalities will have the big Pelican sweepers for street cleaning. Those also work as long as they run them dry. They don't want to run the water and pack it down in there. You can use power wash, and we found that to be fairly effective of blowing out the joint material, sweeping off the crust and debris, and then refilling the joint. And in some cases, the worst case scenario is actually to remove the pavers, clean out all the joint material, clean out any kind of contaminated joint aggregate, and reinstate the pavers. So that is also an option, worst case scenario. There are ways to actually clean this fairly quick using a suction truck. So this actually will sweep and flip out the joint material in front of it, and then the vacuum truck plate comes along and sucks out the material. Hopefully everyone can see this on their screen, where it's actually pulling out the material as it goes over the surface. This generally, depending on what type of joint material it is and how wide, will vacuum out anywhere from about 1 to 3 inches of material. So you could actually get the full depth of the paver in this case. This has a little bit more challenges with the porous asphalt and porous concrete systems, because it will suck from other areas. It's also much harder to pull out from deeper into the system. A recent test study was done with this Cyclone vacuum truck. This actually has a power washing blade that spins, and then it also sucks up at the same time, so it kind of does both. And this study looked at both porous asphalt, porous concrete, and interlocking concrete pavers. And if you look at the box here where it's outlined in red, this is showing that initially, before they did any kind of cleaning, that the infiltration rate for the permeable pavers was less than 20 inches per hour. They went through with one pass, they measured again, and it jumped up to 327 inches per hour. So it basically restored that after one pass. And if you look at the asphalt and porous concrete systems, even after 2 passes, they still remained 70, 80 inches per hour. So they weren't quite as effective of removal of that debris. And that's just because it gets packed down in that maze of the matrix and harder to pull out. So it can be a very effective solution for using cleaning. I tout preventative maintenance. If you wait till you get to having to use these different suction devices, they can be expensive and challenging. A local contractor here came up with this jet wash system that sprays, power washes entire permeable surface. And you can see where they blow out the joint material and they go back and they'll vacuum that system up. But it is very effective at cleaning the surface, believe it or not. So how does that tie back into your infiltration rate? We've created this theoretical chart here that kind of shows you your maximum infiltration rate with a diagonal line running down at an angle here. And this shows what would happen if you didn't do any maintenance. Now this is theoretical. We're assuming after 15 years of regular use for like a parking lot area, it would completely clog up. It could be much longer than that. It could be 20 or 30 years. The one project back in 2017 has been in, 2003 has been in for 17 years. So we're still looking at that data. If you did preventative maintenance, you could extend that out much longer period of time. So again, this dash purple line here is the theoretical what it would be if you did annual maintenance of picking up leaf litter, garbage, things like that, flowers off the trees. And then here you see your green, yellow, and red lines. It's kind of like all right, you have a warning, your 100-year mark has been hit, your 10-year mark, and your 2-year intensity. So very low here on the 2-year intensity. If you're not capturing your 2-year intensity, you're in trouble. So doing preventative maintenance will help that. And then we're also showing a restorative, what that can do if you restore it. Again, it's going to extend that line out longer. So you have a little bit of a window of opportunity there to kind of make sure you're staying on top of maintenance. If you have any more questions about this, feel free to reach out. And if Damien, you want to jump in with any questions now?
Yeah, I mean, you've been on a roll, but we definitely have a couple that are more related to the climate and water
We
infiltration.
lose
So
Damien?
oh, hello?
We'll come back to the question. I think I'll keep going unless Damien jumps in here in a
Hello?
second.
You there?
So we keep time-wise keep going here. So let's talk about some design considerations for
Hello?
the project. There's always some key components to this, and I just kind of want to explain that. With any project, you got to look at planning. What are the goals? It's always good when you get your geotechnical report. What are your site soils? What are the environmental impacts? Are you adjacent to lakes, like in this photo here? And every agency is going to have different requirements. So you need to check to see what they're going to allow for permeable systems. Conceptually, there's kind of 3 ways you might want to design your system. The first way would be if you have very poor soil, so less than a ½ inch an hour is kind of the rule of thumb. You want to put a perforated pipe there at the bottom so water will drain out. Now this could drain to a creek, or it could drain to a manhole structure that connects to your municipal system. So it's not going to always daylight like that. So you can grab that water as quick as possible. The second option would be if you have decent soils where maybe you're around that ½ inch hour mark, you want to capture that first inch or 2 inches of rainfall and get that back down into your subgrade soils. You could raise this discharge pipe up, or you could actually leave it like it was in the last slide at the bottom, but put a restrictor in the manhole for that and back that detention pond out, because you really want to slow that water down. And the third option would be if you have very high infiltration rate soils. So like the projects I've mentioned where they have 14 inches an hour of sandy soils, water is going to run right back through that system back into the ground. But we also have to look at the structural component. You can't just go out there and put in 3 or 4 inches of stone and capture the water you need for your quantity and then drive bus traffic across that. So you do need to look at your structural component of that. It's going to spread out in a cone-shaped fashion, and you want to stay on top of those subgrade soils so they don't settle into the base for that. So you can drive heavy-duty vehicles across it as well. Now, regardless of whether you're using pavers, asphalt, or porous concrete, they're all going to use the same base and sub-base materials, which has about a 40% porosity. It's all crushed angular stone, so it locks together. You're going to go over it with a compactor just like you would as a dense graded material, and really you're going to consolidate that. You want to get it so that it's locked together in place. And 3 inches of stone will store approximately 1 inch of water. We say 24 hours is a good rule of thumb to get it out of the base so that you don't compromise your subgrade soils, which really your subgrade soils look at the CBR, California Bearing Ratio, of up to 72 hours, but you really don't want to wait that long. Here's a photo of Buckingham on the right, where they're doing the installation with the compactors and rollers out there. And you're looking at, for your base, ASTM number 57, and that's like a 3/4 inch clean, no fines. Your sub base typically will be about a ASTM number 2, which is a 3-inch stone. And again, these are going to have 500 to 1,000 plus inches per hour minimum. The nice thing about the ASTM number 2, it adds really a good structural thickness over the subgrade soils and keeps it from settling. The pavers will need a setting bed of an ASTM number 8, so you get a nice level course. There's no sand, there's no geotextile in between these layers. It's going to lock into place and choke out so they don't migrate. So if you stack these up, these are kind of in scale with what the paver size might look like. Again, as I mentioned, if you're using porous asphalt or porous concrete, they're going to use the 2 images on the right for their base and sub-base area. And then with pavers, you do need to have a joint material. Again, you're not using sand, you're using crushed angular chip. We've looked at many different chip types that go in the joints, and we kind of want to make sure that you have the right material for high infiltration rate, but also you have lockup for that. So we've got different options out there we've compared, and something to consider. Now we feel that the joint material is a key component of the system because you don't want these to start to move or slide around. In this case, you can see where they started to open up. You can easily get a bike tire in there, or it could be a trip hazard, and it also collects more debris that way. If the joint material is filled up to the lip of the paver, it's going to blow off the surface a lot easier, be swept up. So that is a key thing we want to look at that. Now I do want to talk about the concrete pavers just in general because they are manufactured the same as a non-permeable paver. It's really the spacing between the joints. So we look at ASTM C936, and that looks at the absorption and compressive strength, which is really one of the key things that people look at. But also you need to consider the freeze-thaw durability, where they put the paver in a tank of a saline solution. They freeze it for 50 cycles, and it can't have a certain amount of breakdown. It can't fall apart. 225 grams of breakage. And then abrasion durability is how well that surface wears before it wears out. The minimum PSI for concrete pavers is 7,200 with about a 5% average. We're a little bit higher. We're closer to 8,500 with about a 4% average. Your porous concrete, average concrete might be anywhere from 2,700 to 5,500 PSI after your 28-day breaks. So we'll get to 8,500 in a few days of curing. And we do send everything out for third-party testing. You can see in this test result right here, the compressive strength is right around 11,000 PSI for this permeable paver. There are many different styles out there on the market, so you can definitely do things for different options, and you have a lot of different scenarios. So this is a product we call Optelec that we license for our big parking lots. It goes in mechanically very quickly. When you see it up close, it really doesn't look like a permeable paver or what we call an L-shaped paver, but this is designed to lock in so it doesn't shift or move around. Again, it's been used in many different parking lots like these projects here, where they've put it in a large scale. This one was 100,000 square feet of permeable pavers. EcoPrior also can be mechanically installed, which is nice for these larger projects where you can put this in this configuration, or you can manually install it by hand, which is also nice. You've probably seen this photo if you've ever picked up a landscape architecture magazine. This is a project here in Chicago with the Sears Tower photobombing my photos again, and this is all permeable pavement around this decorative fountain area. And again, you can put it in sidewalks and parking lots as well. And this uses a higher end finish. Again, this style is a plank style here where it's continuous running bond, where you can put this in and you can still drive on this. This is actually a 4-inch thick paver, so it's pretty durable. But again, anywhere from parking lots to plaza areas for this. And then this is one that we developed for Navy Pier a few years ago, where they actually have it running the entire length of the pier. Most of it's non-permeable, except for this area up front here, and the sidewalk is actually a permeable area, so you have that combination. And even in corporate drop-offs, like here out at Radio Flyer, where they've used the 3x12 permeable shape. Again, more plazas. This town hall is a wet cast material. It's made to replicate a natural brick material. This was used at a spine on a campus here in Illinois to replicate kind of a historic street area. And then even a hexagon, you can get this style in a permeable paver, so water will flow back through the joints. And actually is a really good paver for vehicular areas. It locks together very well and lays in 6 different lane directions, which is nice. Thornberry, again, is a more decorative, large scale. But again, you can see these different styles really give a different effect to how it fits in that space. And even a cobble. You can even get a cobble in a permeable system. So not all these are created equal. There are some different finishes and manufacturing styles. So we make what we call a face mix or EnduraColor product where it has large aggregates in the base and a weathering course on top so it doesn't fade or change colors. In this case is a brush finish, but there's multiple options out there and these can all be applied to different permeable paver shapes as well, which is one of the huge advantages for designers. You don't have to compromise your aesthetics again by just using, gray or black for the porous asphalt and porous concrete. You have a lot of different aesthetic options for to fit your style of your building. So when you kind of stack these all up, you want to make sure that these are the key components that you have. You may or may not need under drain in each system. Again, it goes back to your soil conditions. You may or may not need geotextile fabric. It just depends on the system that you're working with. The sandy soils will definitely require geotextile. And then your base thicknesses will vary. So typical for parking lots, we'll see a 4-inch layer of the ASTM 57 with a sub base of ASTM number 2, about 10 inches for a combined base depth of about 14. Then you'll have 1.5 inches of the ASTM number 8 and then your pavers. So that's a typical section that you might see for a parking lot area for most clay type soils in the Midwest. And if you need heavy duty roadways traffic, you can always put in a thicker sub base material. In this case, we're showing this orange dashed line through there, or this orange solid line is actually a material called drive grid, which is a triangulated geogrid material to help keep the stone from rolling around in movement. And it kind of works like a snowshoe to stay on top so it doesn't settle or reduces rutting, things like that. Versus your non-permeable system, the big difference is that in a permeable system, it's all open graded stone, no sand. In a non-permeable, you have a sand setting bed of 1 inch and your stone base or concrete base or whatever you're using. There are some mechanical equipment that you need for that, and I just want to show you this video. This is how the mechanical installation device works. It's going to pick up 11 feet at a time, 11 square feet at a time. So they can lay about 5,000 to 8,000 square feet per day. With a couple of machines, they could be laying 10,000 to 20,000 square feet per day if they're really moving quick. And they just set that loose back down on the chip setting bed. They'll have a laborer come over and tap these into place to make sure they're nice and snug, and they'll go back and set the other layer. So essentially they could phase in parking. They could be driving on this by the end of the day after they put this in. There's no cure time, it's ready to go. And it's a fully functional stormwater system. It's going to capture that water and start moving it right away. If you look around, I'm sure there's different projects in your area. We've got over 10 million square feet in the Chicagoland region by itself. I've probably worked on over 500 projects just in permeable projects, if not closer to 1,000 in the 15 years I've been at Unilock. So we've got a lot of experience. In terms of budget numbers, I just kind of want to mention here, because of the different finishes, there are different prices. Typically, I always take the price of the paver and I add about $10 a square foot for installation and base. So your budget numbers could range anywhere from $10 to $12 for large parking lot areas installed with about a 14-inch base, up to $20, $25 per square foot, depending on your location. Now, these will vary by region as well. The mechanical installation will save you about $1.50 per square foot in some locations versus labor. And then the last section I just want to mention, you can get some LEED credits for using permeable pavement. We do have HPDs available for all our products. If you go to the Sustainable Mines or our website, you can find those online for health product declarations of all our products, which is helpful. And then reflectivity is another area that can actually be useful for your project. So we do have over 60 colors that meet the SRI requirement um, for LEED. And then I just want to mention a couple things. There are some resources on our website. We do have a full sheet of kind of your typical permeable paver details. You can use these, you can download these. We also have hatch patterns, and we also have product specifications for permeable pavement systems. So those are all available on our website as well. That's all I had. Hopefully you have a few questions I can answer and go on.
Hey Brad, can you
Thank you
hear
very
me?
much for attending.
Can you hear me, Brad? Still
Hey,
having some technical issues there, but
Damon, are you there? I can't hear you if you are.
Brad, can you hear me? Brad appears to be muted on his end, so we're trying to send him a message, everyone.
I'll go to some questions here. So the first question from Jeff, how do you secure these from settling? You can use stuff like the drive grid, but compaction is really key to that. You know, if you have soils that you're not sure about, you can compact them. You're still going to get benefit no matter what kind of soil you'll have, with certain extreme exceptions, like you're not going to want to put these on a bog or something like that. But for your most typical soils that you have, building structures or other parking lots, you can compact the soils if you need to. If you don't have to, that's ideal. But using drive grid or putting in larger stone will help that. Typically we only see weeds growing if there's soil collecting in the surface joint. So that's a visual clue that you need to go out there and clean that system. So if you do have weeds growing there, make sure you're trying to keep that cleaned out. And again, we don't use sand for joints with permeable pavement. Use all open graded stone, ASTM number 8 or ASTM number 9. How these functions function existing clay. Oh, so clay soils, yeah. Even clay soils, they might have 1/10 of an inch of rain infiltration per hour. So you get a 1/4 inch rainfall. It may take 5-6 hours for that rainfall to soak into that soil, but they will actually absorb into that. So you can get some benefits from using permeable pavements over clay soils. Do you find that permeable pavement causes heat reduction? Oh, yes. So good question. So yeah, permeable pavers or just light colored pavers meeting that SRI are going to reduce the pavement temperature by at least 15-20 degrees over black asphalt. So it is a key consideration for large parking lots. So that's going to help cool down the water as it flows across the surface. In regards to storage capacity, I think I've probably killed that on your calculations. It's an easy calculation to do. Do your cubic feet times 0.4, generally speaking, and that's going to give you your cubic feet of storage capacity. And if you saw our chart, we did convert that to acre feet as well. So if you're working on acre feet, that's something to know about. Oil stains can be a problem. There are oil cleaners out there, so you kind of put it on, it looks like toothpaste, it's going to dry and you can sweep it off. But again, some of the products, some of the face mix products that we make have coatings on them. So again, the coatings are going to help prevent anything from soaking into the paver. You can seal it as well with different sealing options. In frequency of preventative maintenance, we say a couple times a year, at least once in the fall and once in the spring. To clean up leaf litter in the fall, any kind of debris that collects in snow, or just in the wintertime, you might get some different flowering of trees or whatnot, depending on your area. So it's always good to at least do it a couple times a year. Again, I look for visual clues. So after your rainstorm, it's always good to go out there and walk around and see what's going on, to see, are there bird bass out there? And if there's bird bass, are they there for more than an hour? If they're there for more than an hour, you want to make sure you're cleaning those areas. And it might just be an isolated case where there's a low spot and it's collecting dirt. So go out there and clean that out and you might be okay. So I really preach preventative, because you don't want to wait till the maintenance becomes more of an issue. turning forces from vehicle, well, certainly you want to look at using products that interlock. So the best thing to do with pavers, if you're looking at interlock, is to flip them upside down and look at how the pavers lock together. So some of our pavers, you won't see the spacer bars at the surface, you only see it on the footprint. And so looking how those interlock is a key component. So like Eco Priora has a double knuckle to it, so it kind of locks it in place. The surface is not going to wear with pavers like they would with a porous asphalt. We've seen some bad failures of porous concrete actually in our area from tire motions turning. It just grinds that surface up because it looks like a Rice Krispie treat. In our part of the country, ground up concrete is used for road base. You can use ground up concrete as long as it meets that ASTM requirement. Personally, I'm not a big fan of the crushed concrete because I think it's can be inconsistent in terms of its mix. You know, sometimes you'll get pockets where it's very coarse, and sometimes you'll get pockets where it has more sizes in it. So I like the natural limestone. Seems to be screed better, or sieved better, I should say, than other things. In this photo you see on my screen here in the background, I'll slide this over. These are actually white pavers that are embedded into the permeable surface. So these are put in module with the pavers out there. So we actually made a white paver. We've done that on a few projects and it works really well. They never need to go back out there and restripe. I have found that the thermoplastic does not work, and neither does I've got a sample of it here sitting right in front of me. I can't think of what it is. It's a striping that actually cures to the pavement, and it's been causing problems with chippage because it doesn't allow the pavers to flex. The best thing is a latex paint to spray on the surface. Yeah, we do have CEUs for this, so if you want, we can send you a CEU. Shoot me an email, and I'll be happy to send back any certificates as well. I'm not sure the question about clean concrete with it as granite aggregate. I'm not sure I understand that question. Oh, sorry. I'm sorry, Damon. I took you off mute.
Can you hear me there?
No, I can hear you now. I'm sorry.
Okay, no worries.
I'm just rattling on these things. I thought you were lost you somehow.
It's all good. We are very happy to hear that you, or see that you took the initiative to look at the questions and really roll through those. And I mean, you're answering all the questions that I had down for live answering. So yeah, I mean, thank you for doing that. I think we're basically at the end though. Jeff did have one last question, which
sure.
I will for everyone, and we'll just ask live. Do you have any issues with using limestone based aggregate? He's heard that it can hold too much water and stain. Well,
certainly there are some issues with limestone based aggregates. What's the best way to explain it? They can deteriorate if you're not using the right type of aggregate, limestone aggregate. So here in Illinois, we use almost exclusively all limestone aggregates. And once in a while, you'll get a pocket that doesn't meet the IDOT or the Illinois Department of Transportation requirements. So you do have to take that into consideration. But yeah, that can be an issue. But I haven't seen any staining per se. I'm not quite sure what he might mean by that. But generally, I can say that we haven't had too many issues with base having issues with the limestone.
Okay, yeah, no worries. I think, he's saying effluents.
Oh.
To clarify.
Yeah, so with our pavers, we do have some special ingredients in there to prevent efflorescence on the surface. So typically I don't see efflorescence on our pavers. Very rare. I did see one last year, and it actually wasn't from the surface. It was from the bottom of the paver that was stacked on top of it on a pallet, but it easily washed off. So we don't tend to see that very much with our pavers here at Unilock, but yeah, it can happen. And you can just go out there with a cleaner, and a lot of times those can power wash off. If it's really bad, yeah, it can leave a permanent shadow or halo around where that flow is at, but typically I don't see that on Unilock products because of the admixtures we run in our product.
Yeah, awesome. Well, again, we've kind of hit our time limit. We're out of questions, but you know, today's presentation has been really, really great. We've had a lot of feedback, even very early on, saying how good it was. And you know, it's a bit of a new one for us. You know, going down this hardscape path, and no pun intended, but you know, we're really happy to be able to have had Brad on for this presentation and his rooftop hardscapes as well.
Thanks for having me, and thanks for
And
everyone for attending.
yeah, you know, the small audio snafu aside, we've had a lot of questions, and I think just for, you know, everyone's peace of mind out there, we'll send all the questions over to Brad just in case there's, you know, any further dialogue that you guys want to have. I know there was some requests for the some of the spreadsheets and questions about CEUs. So we'll make sure that all those things, you know, get over to Brad. And if anyone wants to rewatch the presentation, this will of course be going up on our website later today. But Brad, thank you once again for
Thanks, Damien. I
putting in the
appreciate it.
time. Yeah, of course. And hopefully we'll get you back again soon for another hardscape webinar.
Sounds great.
But yeah, thanks everyone for attending. Once more, thanks Brad, and have a great weekend,
Thanks,
everyone.
LandFX. Have a great weekend.